everyone. This is Saad Aslam, and in today's video, we are going to solve a LeetCode problem, that is how to invert a binary tree. So, this is a very interesting question to solve. So, before solving this problem, let's first understand the problem statement, and then we will discuss the approach of it, and after that, we will go to the coding part. Okay, so the problem statement here says that you have to invert a binary tree. So given the root of a binary tree, you have to invert the tree and return its root. So here in the example, here you can see the left side has been moved to the right side, and the right subtree has been moved to the left subtree. So it is a simple recursion problem. Like if first you need to understand what is a recursion, and we will solve this problem using recursion. So this is a very interesting question to solve. The other example is simple, like example two, the right child of two has been moved to the left, and the left child has been moved to right. So let's before discussing the approach of it, make sure to subscribe my channel and all the YouTube stuff, and let's go to the whiteboard part to understand the approach of it. So here you can see the example, like the tree we are given and the inverted tree. So let's understand how to invert the binary tree. Okay. So here you can see in the example, why it is not working. Okay, so first take the root. Okay, first the root, and we have to go to the leftmost child of it recursively. The first four will go to two, and two will go to its left child, which is that is one. And as one has no it is a leaf node having no left right child, then this will backtrack to its root. Like one will backtrack to its root, so it will go back to 2. Okay, so it is a post traversal, like both of the child have has to be traversed, and after that the root will be uh, after the root will be traversed after traversing both of its childs. So then as we have traversed through left child, then it will move to the right child. Okay, so let me just why okay, so 2 will go to is 3. Okay, so as 3 has no left and right child, so 3 will backtrack to 2. Okay, so it will again backtrack to 2. And as both of the childs of 2 has we have like traverse through recursively to all of the childs, then we have to swap the childs, like we have to swap 1 with 3. Okay, so like 3 and 1 will be swap with each other, like there will be 3 in this. Oh, let me just write 3 corrective. Okay, okay, 3 and 1. So we have processed this part. Okay, so as 2 is processed, then it will backtrack to 4, its root. Okay, and as there is a right child of 4, then it will go to the its right child. So it will move to 7, and 7 will move to its left child. Okay, so 7 will move here, and as 6 is a leaf node, so it is processed, then it will backtrack to its root again, and then 7 will check its right child, and it is as it is a leaf node, then it will backtrack to its root. Okay, so it will backtrack to its root, and as both of the childs of 7 are processed, then we will swap the both of the childs of it. Okay, so like it swap, we have what were the elements at 9 and 6? Okay, so after swapping, the elements will be something like 9 and 6. Okay, it is not working as correct. Okay, so just write 6 again. Okay, so as both of the childs of 7 are processed, then 7 will backtrack to its root. And as both of the childs of 4 are processed, then what we will do, like we will uh, invert, or we will swap both complete subtrees, right? So we will after, you can say, swapping both of the subtrees, the output will be something like if we move this part here, like suppose what we will do is like move 7 part to the left and 2 part to the right, then this tree will be something like the output here. Okay, like if we swap the 7 subtree, like this complete subtree, if we swap this with this 2, then 7 will move here, 796, and 2 part will go to 231, and in this way the binary tree will be inverted. Okay, so let's we have understand the approach, and we have complete dry run of it. So let's go to the coding part. Okay, so as for coding, we use Java, and here you can see there is the tree node class having left and right nodes and constructors of it. So let's try to implement the code. So first of all, like there is a base condition, like if, let me just check some of the thing, like there is a root. Uh, so if root is null, like for base condition, if root is null, then we have to just return to the root. Okay, and as we have checked that we have to recursively move to right and left child. Okay, so first of all, what we will do is we will make a tree node, like type of tree node, like the one is the class given, and tree node left. And what we will do is call the invert tree and move to the its left child. And similarly, we will, after traversing through like all of the depth of left, like if we have traversed through the leaf node of left, then after that we will move to its right, then invert, and we will go to root dot right. Okay, so we have like move recursively go through the leaf node, and now we have to swap both of the elements as we have discussed. So what we have to do is swap the elements, like root dot right will be assigned the left, and root dot left will be assigned the right, and we have to just return the root. Okay, so as we have like implemented it in the whiteboard, we have implemented the code. Now let's try to run the code. So okay, why it is pending? Why it is taking so much time? Let me just refresh the screen, I think. Okay. Okay, so here you can see the all test cases has been passed, and now let's submit this code. Okay, so here you can see 100% runtime and memory usage. So there's the way of inverting a binary tree. So I hope you understand the problem, and it is a basic recursion problem, and it is a good problem to implement recursion uh, and using logic of inverting a binary tree. So that's it for today's video. Make sure to subscribe my channel to receive notifications of other videos in the competitive programming series, and see you in the next video. Bye bye.